elements with maximum frequency. Okay. You are given an array nums consisting of positive integers. Return the total frequencies of elements in nums such that those elements all have maximum frequency of an element is the number of uh, such that all elements have maximum frequency. The frequency of an element is the number of occurrences of that element in that array. Okay. So the question is very much straightforward. Uh, in this question, what you need to do is that you need to count like all different elements occurring in the array. For example, here we have four different elements occurring in the array, which are 1, 2, 3, and 4. Okay. Uh, okay. The elements 1 have frequency 2, element 2 also has frequency 2, 3 has frequency 1, 4 has frequency 1. Okay. So what is the maximum frequency of element present in this array?
2.
2. And how many elements have this maximum frequency?
Oh, 4.
Right. 4 elements have this maximum frequency. 2 have got 2 are 1 and 1, and 2 are 2 and 2. So total we have 4 elements which have the maximum frequency. Here if we come to this question, here we have got 5 unique elements. Here 1 has got frequency 1, 2 has got frequency 1, 3 has got frequency 1, 4 has got frequency 1, 5 has got frequency 1. Okay. So now uh, let's come to the problem. So what's the maximum frequency of the elements present in this array? 1 again.
1, 1.
Okay. And right. So
5
how many
again.
elements have this one frequency? 5 elements. Okay. So simply what we can do is that we can create a map. In that map, we can store frequency of every element occurring in the array. For example, here we'll store all the elements occurring in the array, and in that map, we'll increment the frequency of every element occurring. Okay. Now, in the second iteration, what we can do is that we can iterate over the map to check what is the maximum frequency of any individual element. So in second step, we'll find the maximum frequency. And once we have found that maximum frequency in that array, what we can do is that we need to find all the elements which have this frequency, right? So here in the second step, we found out the maximum frequency is 2. Now we'll find out how many elements have this uh, maximum frequency as 2. So here 1 and 2, these two have maximum frequency as 2. So total how many elements are there? We can calculate the total elements as 2 into 2, which is first frequency and then the number of elements which have same frequency. So yeah, I hope the question is very much clear.
Yes.
Okay, so let's jump to the second problem. Find beautiful indices in the given array. Okay, so this is the first problem, and the last problem is also the same, just they have changed the constraint only, I guess. Okay.
लास्ट भी सेम ही था, कंस्ट्रेंट चेंज करे शायद.
Yes, the constraints are changed for the last problem. So here what the question says, you are given a zero index string s a string A and a string B and an integer K. Okay. And index I is beautiful if 0 is greater than I is greater than equal to 0 and less than equal to s dot length minus a dot length. Okay. So first of all, what we need to find is that for any particular index of I, we need to find the element, we need to find the string A in that particular array. Okay, S. All of them should be occurring one after the another only. Like the whole word should be present in continuation. And we need to find another index J such that again J should be in the range of the string S only, and string uh, B can also be found in between that indices. Okay, so it's very hard to speak these in terms of indices and all values. So let's come directly to the problem and see. And this one constraint they have mentioned that J minus I mod should be less than or equal to K. Okay, so here, first of all, we are given this string is ISAWS SQUI RREL NEARMY SQI RREL HOUSEOHMY. Okay. So the two words are two words are squirrel
Two.
and
My.
my. Okay. So let's read this question again. So finally, an index I is beautiful if, first of all, we need to find an index I such that from starting from I, we can find that particular word A. Okay. And from that I, okay, from that I, we need to find an index J such that J is at J can be at max at a distance of K from that I, and from that index J, we can find that another word B, which we are given again in the question. So let's see here first. So again, for finding a word in an array or finding a word in a string, it's a simple pattern matching question, right? Have you solved this kind of question previously also, Aniket?
Yes, sir. I have done this
Oh,
type of.
so first of all, what we'll do is that we'll find all the occurrences of string A in the array. Okay. So
uh,
string A is my. So
My.
my is present at this index. Okay. And again at this index, right?
Yes.
So let's see the index also. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, okay, 34. So at what all index we can find my? First of all, we were able to find my at this index 16. Okay, so I have written very small. I don't know if you will be able to understand. So this probably looks like my is probably looks like 17. So m should be 16 only. So my is present at 16 index and then also present at the 33rd index. Okay.
Yes, sir.
Now, at what all index we can find squirrel, the word squirrel. So squirrel is first of all present at this index.
Uh,
Okay. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 4. Okay. Fourth index.
Fourth.
And then here again at, I guess it is
Uh,
18th index.
18th.
Okay. So here we have got two occurrences of string A and two occurrences of a string B
B.
also. Okay. So now what we'll need to do next.
We can just iterate over the string.
Right.
And then first we have stored the index, so like we will get to know whether A is formed at that particular index or not. Like if
Right.
we come to 16, so we'll know that A is forming. And then we can check in the B array that this condition is satisfied or not. J minus A is less than K.
Right.
Uh, for
Right. Right.
that, I
W-
think we can.
We can do that thing. All right. First of all, what we'll need to do is that suppose we have to find like what all elements we can tolerate. We can tolerate up to 19 for this B, 19 or wait, 4, 19 minus 4 is 15, right?
Minus 15 to 19, basically.
Right. So we can tolerate up to 19 to minus 11. So minus 11 won't be an index, a valid index. So it can
Uh,
tolerate up to 0 to
0
19.
to 19.
Okay. And for 18, what all range of indices it can tolerate from 3 to
3 to max of n minus 1 or 18 plus 15, 33.
right. So it should come like
Minimum of, sorry, n minus 1 and 33.
right. So here it will be 83 comma 33. Okay. So we have got ranges. Like in this range, we can have if an element is there, it can pair up with B.
Uh,
In this range, if we have any element in A, it can also pair up with another element in B. Okay. So what we need to do now, we have got ranges, like we need to find an element which should be greater than 0, greater than or equal to 0, and less than or equal to 19. So what we'll do,
we can combine them, for example, 0 to 33.
no, no, no. Right. What we can do is that we can do a binary search. So, uh,
Lower bound or upper
right,
bound.
right. Let's take a quick short example. 1, 2, 3, 4, 4, 5, 6, 7. Now we need to find all elements which are uh, in the range of 3 to 6. Okay. What we'll do, we will apply upper bound at 6. Okay.
Uh,
Upper bound at 6 will give what index?
Last two,
This index, right?
matlab 7, but
Okay. So what does upper bound tells? Upper bound tells that element. It gives index to that element which is not less than the number you have passed. So first element which is not less than 6 is 7. So it will return index to this 7.
Uh,
0, 1, 2, 3, 4, 5, 6, 7. So these are all the indices. Let me change the
not
color.
less, मतलब equal to as well, ना?
Yeah,
Equal to भी नहीं होगा ना?
no. Which should be
Greater than.
greater than 6.
Uh,
Okay. So the first element which is greater than 6 is 7 and it is present here. And then what we'll do? We will do lower bound on 3. So lower bound on 3 means what? The first element which is not less than 3. Here, not less than 3 means that it can be equal to 3 also. Okay. If 3 is present, then 3 can be there. If 3 is not present, then we'll look for the first element which is not less than 3. Okay. So if not 3, then we will look for 4. If not 4, we'll look for 5. Okay. But if 3 is there, then the first element which is not less than 3 is 3 itself. Right? Clear?
hmm.
So here the
Yes.
it will return index to this element, this index 2. Okay. Now what we'll do, we need to find out the number of elements. So we'll subtract this indices and we'll get our answer. This is 5. And we can check, we have got 5 elements. 1, 2, 3, 4, 5. 5 elements in the range of 3 to 6.
Hmm.
Let's try another example. Let's try another example and see if it holds consistent with our result.
3 to 6. Oh,
So we need to find elements in the range of 10 to 17. Okay. So what we'll do? We'll do an upper bound on 17. Upper bound on 17 will mean first
18.
element which is not less than 17,
18.
right? Sorry, not less than, sorry, I'm telling wrong thing. Which is
Greater
greater
than.
than 17?
18.
So it is 18 only. And first element, now we'll apply lower bound on 10. First element which is not less than 10,
13.
13. So it will come out, so for example, its index is 0, 1, 2. So the difference will come out to be 2. So we have got two elements which are in the range of 10 to 17 in this particular array. So I hope this approach is very much clear.
Oh,
So our task can be divided into two things. What? First of all, we'll need to find all the occurrences of A in the array in the string S, and then all the occurrences of B in a string S, store their indices. Then for every particular index, what we know is that we'll need to find a range. Like for 4 till 19, if any index is present in A, we can tolerate that because 19 minus 4 will be equal to 15 and K is 15. So we can tolerate up to 15 difference. The absolute difference cannot exceed 15, right? It was given here. So it was given here that the absolute difference cannot exceed the value K, which is given here. So this you need to find that, yeah, the difference here is 15. For that, in what range can it accept number? So it can accept number in range from 0 to 19.
0 to
And in 0 to 19, how many elements we have? We have got one element, which is 16.
19.
Now for 18, what's the range? The range is from 3 to 33. 33. Okay. And how many elements are in that range? Only one element here again. So we'll have two such beautiful indices, 16 and 33. So I hope it is clear. Or actually, we'll need to do it in other order. Like we'll need to search for indices in A to the indices in B. Then we can point out, yeah, this was 16, this was 33, around which we could find the elements.
हाँ बिकॉज अगर मतलब 18 में तो फिर 16 दोबारा कवर नहीं हो जाएगा मतलब दोबारा एंड क्योंकि फॉर
No,
18 के लिए भी
we'll
16 वैलिड है
first of all, what we'll need to do is that we'll verify for this index. Okay. For 16, what's the acceptable range? It's from 1 to 31. Okay. Is there an element which is present in this range in array B? Yes, there are two elements which are present in array B which fall in this range. Okay. So we can count 16 as a beautiful index. Then we'll move to 13. We'll skip 16 after this. Once a matching is found, we'll skip that index. We'll then go to 33. So what's the
हाँ
acceptable range for 33? It's
ठीक
from
है ठीक
8 to
4 18 ओके
okay. Sorry, 18 to 33 only, 34 only. So we have got one element. So that's the thing. And for string finding, you'll need to use KMP algorithm.
स्लाइडिंग विंडो से नहीं कर सकते स्लाइडिंग विंडो से भी पॉसिबल है
For this one, your it will pass, but for other question, the last question, it won't pass until you use KMP algorithm.
अब वाई बिकॉज मतलब कॉम्प्लेक्सिटी तो एल लॉग एन ही हो रही है ना
No, but string pattern matching, it
अच्छा
takes
स्ट्रिंग है
right.
ओके
So let's come to the last problem. Here, see, the constraint are both the lengths can be also 5 into
10
10
की
to the power
पावर
5,
5
right?
ओके
And here the lengths were only 10. So the string finding procedure will take n into m, which will be 10 to the power 6, which is acceptable. Then you will be doing binary search, which is again acceptable thing. But here it will go beyond uh, our normal time frame if we use this a simple string search algorithm. Instead, we can use KMP.
ओके
Okay. Now let's come to this problem. Maximum number that sum of the price is less than or equal to k. Okay, so this is the problem name. Uh, let's read the problem statement. Is the screen visible?
विजिबल
Okay, you are given an integer k and an integer x. Consider s is the one indexed binary representation of an integer num. Okay, the price of a number num is the number of i's such that I modulo x is equal to 0 and s of I is a set bit. Okay. So return the greatest number num such that sum of prices of all numbers from 1 to num is less than or equal to k. So these kind of questions previously they used to come in code forces only, but this time they have asked this kind of question like in recent times they are asking such kind of questions in uh, lead code also. So there's nothing much to the problem statement. Let's jump into the example and see what is there. So here, okay. So as you can see, the range is pretty high here. K can be up to 10 to the power 15. Okay. So
Oh,
10 to the power 15 means excessively large number. And what is 10 to the power 15 means?
15 bits.
No, not exactly. So here, like 2 to the power 10 is equal to what? 1024.
1024.
Then 2 to the power 20 is equal to
Oh,
somewhere
10,
around, let us count
10,
it as 10 to the
10 to
power,
power 6 around.
right? Let us count it as 10 to the power 3 only for our convenience, not exact
Uh-huh.
maths.
Uh,
Okay. So then
10 to
it will
power
be 10 to the
6.
power 6. Again, 2 in 2 to the power 10, it will become 10 to the power 9. So it is exact around, it will come out to be 32-bit number. Okay. So since we have taken a lot of consideration into 24, we have ignored. So that's why it's coming to the power 30. Now let's come to 2 to the power 10. Let's multiply 2 to the power 10 again. What will it become? It will become 10 to the power 12. Okay. Then again, let's multiply it with 2 to the power 10. It will become 10 to the power 15. Okay. So k can be up to 10 to the power 15. So see how big the number has become. 10, 20, 30, 40, 50. 50 bits after approximation. We have ignored 24 5 times. That will again result in a very big number, right? You can see. So 10 to the power 15 is around 50
Oh, I
plus
was
for
doing it 2 to
approximation.
the power
Let's
15.
yes, for approximation, let's take 24 to the power 5 is how much? 576 into 576. Okay, so this will be around 25,000
Uh,
into 24. So this will be again around uh, how much?
oh, 625,
L- let's let's take around
600,
it.
6 into 10 to power 5 around
Right. Let's take around
5 10 to
stay
the
on.
power 5.
Right. It will be around 10 to the power 5. For even better error handling, let's take up to 8. Okay. So 10 to the power 15 will be around, let's say 60 at max, it can be a 60-bit number. Okay.
10 to the power
10 to the power 15 can be at max. It will
60
be
bit.
within 10 to the power 60. Sorry,
Uh,
it will be within 60 bit. All the
uh,
10 to the power 15 elements, power elements, can be represented in a 60-bit number. Is it clear? So this is a very simple thing which we use for approximation of how many bits we'll be needing. Okay. So now let's come to another thing. So what we'll do here, what we'll do is that we need to find, like for uh, let's take the first example, then it will become clear. Otherwise, it's very tough to discuss this problem verbally. So here k is equal to 9 and x is equal to 1. Okay. So x is equal to 1 means, and first of all, it is given that the binary representation is a one indexed array. So all the index are 1, 2, 3, 4, 5. So all the index when modulo by 1 will become 0 only. 1 modulo 1, 0, 2 modulo 1, 0, 3 modulo 1, 0, 4 modulo 1, 0, 5 modulo 1 is again 0. So all the indices will be counted. All the indices will be counted. So now let's come to our number. So first of all, we'll have 1, okay. Then we'll have 2, okay. Then we'll have 3, okay. Till this point, what is our total price? 1, 2, then again 2 bits are set here, so the total price becomes 4. Then next element will be 4. 4 will look something like this. So it will contribute 1 bit. So total cost becomes 5. Then comes uh, 6. 6 is something like this. It will contribute 2. Then comes 7. Hello.
Oh yeah, 7.
Okay, okay, sorry. After 4, 5 will come. 5 will look something like this and it will contribute 2 bits. Then comes 6. It will contribute 2 bits and it will become 9. So exactly we have reached the total
Total
price
sum.
9. Okay. So if we include further elements, like if we include 7 again, so 7 has 3 set bits. So it will increase our price, total price by 3, and it will
3.
exceed our value by of k, which we are given. So our sum will increase, right? So we'll skip this number. Clear?
हाँ ये क्लियर है मतलब सिंपल ही x इज इक्वल टू 1 है तो सिंपल हो गया
Okay. So now let's come to the second example, which is a bit better than this. What we can do for this example, let's come to this example. K is equal to 7 and x is equal to 2. So let's take the first number 1. So 1 has 1 bit set. So for 2, which all bits will be considering? 2, 4,
2
6,
4 6
8,
8
10. Likewise, we'll check for all the even indices. So 1 doesn't contribute to any price. 2 has bit representation like this. So it will contribute 1. 3 will contribute 1. 4 will contribute 1. 5 will contribute, sorry, 4 won't contribute at all because 4 has third bit set. So 4 won't contribute. 5 again won't contribute at all. 6, uh, sorry, 6 will contribute 1. 7 will contribute again 1. 8,
1
1. 9 will
2
no.
नहीं हाँ 1 1
Okay. So let's see how many elements to all the elements we have included. What's the total price we have got? The total price we have
8
got is
8
1,
will be 0
2,
ना 8
see 1, 2, 3, 4. Fourth bit is set. So it will be counted.
ये 8 0 0 0 1 कैसे
8, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 0, 0, 0, 1, 8.
अच्छा ओ लेफ्ट टू राइट मेरे को लगा कि हाँ ठीक है ठीक
I have written in like the
हाँ ठीक है
okay. So our price becomes total 1, 2, 3, 4, 5, 6. Now let's try another element. Let's try. Let's try uh, 10 also. We have reached till
k is
9.
equal to 10.
Hmm. So it will become 0, 1, 0, 1. So it 10 will contribute how many bits? 2, right? Because its
2, 2.
second bit and fourth bit are set, so it will contribute 2 to the price. And what was the total price till now? 1, 2, 3, 4, 5, 6. 6 plus 2 becomes 8.
8.
So yeah, here if we include 10, then our price will become
Greater
greater
than
than. So the maximum element which we can include is up to 9.
9.
So this approach is very much clear. This approach is clear, right?
Approach is clear, but how
How
to
do we
do?
implement this?
How
S-
do?
So one thing what we are trying to do, we first of all let's break down this problem. First of all, what we are doing, we are searching for the element, s- the element up to which the sum of all the uh, what we can say potential bits is less than equal to k, right? And how we are going? We are going linearly. Like first we are going to 1, then we are going to 2, then we are going to 3, then we are going to 4, then we are
4
going to 5. This way we are going linearly.
linearly.
Instead, what we can do? We can do binary search here.
Research. Hmm.
How? Let's take this example. First of all, let's take this example. Okay. So mm, here,
Find
uh,
research on K for K.
right, the sum of all the candidate set bits should be less than or equal to k up to
Okay.
elements. Okay. So let's take the lower limit as 0 and upper limit as 20 here. So the mid comes out to be 10.
10.
Okay. Then we look for uh, what we'll do is that we will find out some of all the potential set bits from 0 to 10. Okay.
ठीक है.
And it comes out to be 8 because we have calculated it here only. So it comes out to be 8. It comes out to be 8.
8.
So what does it mean? It
That
means
10 is a suitable answer.
no, no. 10 is giving us.
More than K. Oh, it's not suitable.
So we need to search in the range of 0 to.
Left range 0 to 10.
Okay, 0 to 10. So where will we search? We'll search
5.
for 5. Okay. So let's search for 5. So 5 up to 5. How many set bits were we were getting? We were getting only 2 set bits. So it is less than k. So we'll then search to 5 to 10. Then we'll search for 7. Then again for 7 also, we are getting less than or equal to k. Then we'll advance our search to the remaining half, which comes out to be 7 to 10. For 7 to 8, we'll advance our search to 8 to 10. From there, we'll narrow down our search to 9 to 10. And finally, 9 comes out to be our answer. Okay. So this
हाँ,
is a binary search problem, because what we are doing is we are trying to find a possible candidate K, a possible candidate for which sum from 1 to that particular element is
valid, less than k.
less than or equal to K. So for that we can do binary search.
लेकिन we have to, you know, find the submit in O1 operation somehow.
Right. So first of all, what we are doing, we are dividing the number into bits, and at max, what can be the highest bit set for a 15-bit number?
If 50, 60,
Let's take 60.
60,
So we'll iterate over this array only,
0 to 60.
right? So we'll have this array, sorry, 1 to 60, and we'll find out all the possible indices which are, for example, this for this case, it is 2, 2, 4, 8, 2, 4, 6, 8, 10, 12. Likewise, for every particular element, we can find out all the possible candidates, and we'll look only for them. So even bigger numbers break down to 60 bit at max.
60 bit at max.
Okay. So what we will do is that again, we'll break down all the numbers, and we'll try to do binary search on, like, again, what we are doing here. We were doing linear search in the beginning, that up to 1 we will check, up to 2 we will check, up to 3 we will check, 4 we will check, 5 we will check, 6 we will check. So we were doing binary, sorry, linear search. But this range is a sorted range. This range is a sorted range.
Not at range.
Okay. And after knowing that this range is a sorted range only, what we can do? We can do binary search, right? Is that clear?
Clear.
Okay. So try implementing this. If you have any issue again, then you
Okay.
can ask in the next class.
ठीक है भैया.
Okay.
Okay. Good night.
Although this was a very good question.
Hmm.
Okay. So again, give that code chef contest this weekend. Okay. Then
ठीक
we'll
है.
discuss that code chef contest also.
ठीक है. Wednesday or Thursday.